Hi everybody, welcome back. Continuing with example 1, we finished this example, but we now want to see how do we do the same thing without relying on the graph. That is, how do we extract that same information from this problem if all we have to work with is just the formula itself using algebra. So that's the idea. We're going to go through the same problem again. It will just take a few minutes and we'll get the same answer, I hope. But you're going to see how this comes from the graph and sort of in your heads comparing the algebra method and connecting it to the picture that's going on. That's really helpful. So the more that you can hold some kind of picture in your head as you're doing the algebra, it can help give the algebra some meaning, which can help smooth the way for what we're doing here. Let's give it a try. So I just want to make an observation. The question says x squared minus 3x minus 4 is greater than or equal to 0. And the left-hand side, what we did was we drew that as a function here. And we're interested in knowing for this function where it's greater than or equal to 0. That means where it's positive or 0. And that corresponds to looking at the places where the graph lies above the x-axis, which is here and here. Now, if we didn't have the graph to work with, the key important idea is as you travel along this function, here it's above the x-axis, and then here it's below the x-axis, and in the middle, what is it? Well, it's equal to 0 in the middle. There's a point there where the function is not above, it's not below, it's just right on the x-axis, and that means it's f of it, that number is equal to 0. That's the number minus 1 here. And there's another number here. If we travel along the function here, we're below the x-axis, but then suddenly we cross, and now we're above. And it's that point where we cross that's important. That's that number 4. And we can find those two numbers, that minus 1 and that 4, by setting the function equal to 0. And once we've done that, it's like we've divided the number line up into sections where these are the dividing points, the edges of those sections. And then it's just a matter of testing the sections to see which ones satisfy the inequality and which ones do not. So that's the general strategy that we're going to be using. Let's go ahead and give it a try. So let's suppose that we are starting this example again. It says x squared minus 3x minus 4 is greater than or equal to 0. And we're supposed to solve this in the absence of any other instructions. And to solve it means give us some kind of list of all of the real numbers x that make this equation true. Okay. If we didn't have the graph to work with, what we would do first is look for those dividing numbers, those numbers on the edges of the regions where it's positive and where it's negative. And we get those by setting the left-hand side, that x squared minus 3x minus 4, equal to 0. So, squared minus 3x minus 4 equals 0. Now, to solve this, this is a quadratic. We could use the quadratic equation, but I think this one factors nicely. We're looking for two numbers that multiply to give negative 4 and add up to negative 3. And those numbers are minus 4 and plus 1. Now, we use the zero product property here. We split this into two equations. We have x minus 4 is equal to 0 and x plus 1 is equal to 0. And then here we add, on the left-hand one, we add 4 to both sides and we get x equal 4. On the right-hand one, we subtract 1 and we get x equal negative 1. So we have two numbers, x equal negative 1 and x equal 4. Those are the two numbers that, when you plug them into the left-hand side of this thing, they turn the whole left-hand side to be equal to 0. All right, let's record that on a number line. It's helpful when you're doing this to record on a number line. Let's put 0 in the middle. Here is negative 1. We'll put a dot there. And then let's see if that's 0. This is 1, 2, 3, 4. So we have these 2 points, the negative 1 and the 4. And the idea is, if we didn't have the graph to look with, we know that these are the places where the graph touches the x-axis. So if it's going to cross the x-axis from either above to below or reverse, it's got to do it at one of these two places. And so if we just think about since there's two dividing lines, I think of these as little dividers. Since there's two dividers here, it gives us three intervals. The interval on the left, the one in the middle, and the one on the right. And the idea is that we don't know now, so if we're starting this problem fresh, we don't know whether the graph of this function is positive over here or negative over here. Yeah? But we know that it doesn't cross the x-axis over here, so it's either all positive or all negative, one or the other. Same in the middle. It may be positive in here, it may be negative in here, but what it does not do is cross the x-axis again in there. So it's either all positive or all negative. And same thing for this interval over here. And what's nice about this is that this has narrowed things down so that instead of having to test infinitely many different numbers, we really just have to test to see whether it's positive or negative on this interval, whether it's positive or negative on this interval, and whether it's positive or negative on this interval. And here's how we do it. We just pick a number in each interval, plug it in, and test it. So for example, here I'm going to choose the number -2. And when I say test x equal -2, what I mean is plug that number into the left-hand side and see whether it does indeed come out. If we plug it in here, does it come out bigger than or equal to 0? All right, let's go ahead and give it a try. If we plug it into the left-hand side, we're going to get -2 squared minus 3 times -2 minus 4. And that is 4 plus 6 minus 4, which is equal to 6. And 6 is definitely bigger than or equal to 0. And that means that in this point right here, -2, the function, the left-hand side function, the x squared minus 3x minus 4, is positive. It's somewhere up above the x-axis. And if it's up above the x-axis here, it has to be up above the x-axis everywhere along here, because it can't cross the x-axis anywhere until it reaches here. That's the first place it can cross the x-axis. So since it's positive at -2, it must be positive everywhere in this interval. And we can just mark that by putting a little plus above this interval. All right, the next idea is that we want to check, is it positive or is it negative in here? Yeah. And we do it the same way, which is by testing. So let's test x equal, well, what's a good number in there? Well, it can be any, not the two endpoints, -1 and 4, but you can do any other. I'm going to choose to test that number 0, x equals 0. And for x equals 0, we have 0 squared minus 3 times 0 minus 4. The whole thing is -4, and that's negative. So that says that this function is negative in this middle interval from -1 up to 4. The function is negative there. It lies underneath the x-axis there. Because at 0, it gives you an answer of -4. It means it must be down below here somewhere. And then lastly, we want to test this third interval over here. We're going to see whether it is the function is positive here or negative here, and we're going to do it by testing a value. So let's choose the number 5. We could have chosen the number 10 or 20 or 100. It doesn't much matter as long as it's in that interval somewhere and it's not one of the endpoints. So test x equal 5. Here we have 5 squared minus 3 times 5 minus 4. And as we saw before, this whole thing is equal to 6, which is also bigger than or equal to 0. And so this function is positive from 4 up to infinity. Okay, so what have we got? Well, we can just put these together into our final answer. Looking at this, what we call sign chart, it's like a number line that tells you where the function is positive, where it's negative, and then also where it's 0. And we want to collect all the places where it is greater than or equal to 0. So that means that we're going to include this interval and also include that endpoint. We're going to include this endpoint and then also include this interval. And we should come up with the same answer as last time. It's minus infinity up to -1, including the endpoint, and then from 4 to infinity. And that's our answer done algebraically.